The objective of this lesson is to construct a 2-digit by 2-digit area model to represent multiplication. Prior to this lesson, students have practiced representing multiplication of 2-digit by 2-digit multiplication by drawing an array using the box line dot method to show partial products. An area model shows the decomposed factors and products for each place value. The term partial product means part of the answer to a multiplication problem. Partial products are added to get the answer. Another term used in this lesson is decompose. The number is broken apart into expanded form. For example, the number 372 is really 300 plus 70 plus 2. Let's solve the following problem by graphing an area model on graph paper. 14 scouts have each earned 23 merit badges. How many merit badges have they earned altogether? First, decompose both numbers. The 14 is 1 10 and 4 ones. The 23 is 2 10s and 3 ones. Draw a rectangle that is 14 by 23. Write the decomposed numbers along the left and top of the rectangle. On the left, write a 10 and a 4. On the top of the rectangle, write 20 and 3. Next, draw a vertical line at the 20th square and a horizontal line at the 10th square. This creates the 4 sections of the rectangle that will correspond with the 4 partial products. Multiply the width and length of the upper left section, which is 10 times 20 equals 200. Write the equation in the box. Then multiply the dimensions of the upper right section. 10 times 3 equals 30. Write that equation in the corresponding box. Now multiply 4 times 20 and write the equation 4 times 20 equals 80 in the lower left box. Finally, multiply the 4 times 3 equals 12 for the total number of squares in the last box. Each partial product is the exact number of squares in that section and represents the numbers added for the total product. 200 plus 30 plus 80 plus 12 equals 322. As students transition to more traditional methods of multiplying, they will recognize the same partial products as they complete the computation. Let's try another problem. 16 students are competing in a marble tournament. If they each need to start the competition with 34 marbles, what is the total number of marbles needed for the tournament? First, decompose the numbers. 16 times 34. 16 equals 10 plus 6, and 34 equals 30 plus 4. Use the graph paper to draw a rectangle 16 by 34. Write the decomposed numbers along the left and top of the rectangle. On the left side, write 10 and 6. On the top of the rectangle, write 30 and 4. Then draw a vertical line at the 30th square and a horizontal line at the 10th square. This creates the 4 sections of the rectangle that will correspond with the 4 partial products. Multiply the width and length of the upper left section, which is 10 times 30 equals 300. Write that equation in the box. Multiply the dimensions of the upper right section. 10 times 4 equals 40. Write that equation in the corresponding box. Next, multiply 6 times 30 and write the equation 6 times 30 equals 180 in the lower left box. Last, multiply 6 times 4 equals 24 for the total number of squares in the lower right box. Each partial product is the exact number of squares in the sections and represents the partial products added for the total product. 300 plus 40 plus 180 plus 24 equals 544. So 16 times 34 equals 544. Graphing area models will help students begin to visualize multiplication. The objective of this lesson was to construct a 2-digit by 2-digit area model to represent multiplication. We met this objective by drawing an area model on graph paper that was proportional to the partial products and then added together for the total product.